Okay, so those of you watching this video are either going to BC or you're just excited and curious on how to do these without a calculator. I think this is kind of fun, but then again, I'm your math teacher. Okay, so in order to do this, you first graph what this would be in rectangular coordinates. So we have y equals 5 cosine theta. So we'd go here and make our graph. We'd go up 5, and we'd go down to 5. These main points would be at 2 pi, pi. This point right here would be pi over 2, and 3 pi over 2. So in order to graph this by hand, we would have to know that this is a circle, so that we know what basic shape we're having. We're going to do these main points. We're going to be doing this point, this one, this one, this one, and this one. These are the 5 points we are going to graph as part of our circle, which you'll find out are not necessarily 5 points. So at 0, we'd go out to 5. 1, 2, 3, 4, 5. We know that there's a point there. At pi over 2, we're back to 0, so it would be here. At pi, we'd be at -5. So if you went out here, we'd have to go back here. So this point would actually be a double point. 3 pi over 2 is back here at 0, and then 2 pi is here. So you really only have 2 points, but if we know it's a circle, you should make this as circle-like as possible, and you know the basic shape. That's what you need to know for BC, is basically where it's at, which quadrant is it in, stuff like that. So you don't need to know exact points for that first quadrant or that fourth quadrant, but you need to know that it's in those 2 quadrants. The next one we need to know is a limnason and a basic shape of what this looks like. This is also what tells me that things have loops. So this is 1 plus 2 sine theta. I was going to draw that in black. So a reminder, this has a vertical shift of 1 up here, and then it has an amplitude of 2. So we would start here, we'd go up here, we'd go down to here and here. So this point right here is 2 pi. This point right here, remember, is pi. This point is pi over 2. And this point is 3 pi over 2. So the 5 points we're going to graph is 0, 1, pi over 2, 3, pi, 1, 3 pi over 2, -1, and 2 pi, 1. So going over here to the polar coordinates, we are going to do 0, and we'd go out to 1. That's right here. Pi over 2, it's up at 3. 1, 2, 3. At pi, it's back at 1, so it's over here. The reason I know this one has a loop is because of this part of the graph right here. Since that part goes negative, that's what makes this a limnason with a loop. So at 3 pi over 2, you would be on the y-axis going down, but since it's -1, you know it goes over here, and then it's back. So you know that this graph starts here, it goes up here like this, it goes down here. You know it's positive in this part, but it comes negative here, and then it loops around like that. You kind of have to follow the graph and connect the points in the correct order to make that work. Here's another limnason. This one won't have a loop, and if you look at it, I was going to do that in black again. Up 3, and then we're going to go up 2 more. It's a sine graph. The main reason we're drawing this graph is just to get those main points. So that's pi over 2. This point right here is pi, 3 pi over 2, and 2 pi. See how this rectangular trig graph does not go below the y-axis? That's when I know there will not be a loop. So 1, 2, 3 out here. Let me 0, 3. Pi over 2, 5. 1, 2, 3, 4, 5. Pi, 3. 3 pi over 2 is still positive, and then 2 pi. it doesn't really matter if this one you have like a little bit of a bump right here or not. I've been told in terms of calculus that looks pretty bad, but you get the idea, that it doesn't matter whether there's that dimple there or if it's flat. Really, what you're going to be doing in BC is finding the area of these things. So you basically need to know where it is in the quadrants and stuff, not necessarily the whole exact shape. So whether you were to draw this with that little dimple or not would be fine. I'm going to skip this 3 sine theta because that's another circle. Let's get to the roses. Okay, here's a rose. I know that because of this 2 theta business right here. Let's see, I would draw my normal graph, but remember this period is now switched. It's now pi. But in order to do this in polar coordinates, we do need to go to 2 pi. So this point now would be pi over 2. Here would be pi over 4. Here's 3 pi over 4. Let's see, this point is 3 pi over 2. This point right here is 5 pi over 4. And here is 7 pi over 4. This goes up to 3 and down to negative 3. So at pi over 4 now, you're going out to 3. 1, 2, 3. If you remember that this is a limnason, not a limnason, remember that this is a rose, 1, 2, 3, and you know the basic shape, you're going to know that this leaf goes out here like this. And I went ahead and finished it, but at pi over 2, it would be back here. At 3 pi over 4, which is normally this line right here, but it says it's negative 3. So you have to go backwards, 1, 2, 3. So this graph actually comes over here and then goes back to here at pi. And then at 5 pi over 4, which is this line, it is out to 3 again. And then 7 pi over 4, which is this line right here, it's at negative 3. 1, 2, 3. And it would be over here. So that's how you get your 4 leaves on that one. Now the next one, if you notice, has an odd number right here. So I know that there's going to be 3 leaves. You have to know those basic properties of the polar graphs in order to do it without a calculator. Otherwise, you might get lost in terms of what points you need to draw. So I will draw my cosine graph now, but it's 3 theta. So that means this is a lovely 2 pi over 3. That's pi over 3. This point right here is pi over 6. That's pi over 2. Unfortunately, for these, you should go all the way out to 2 pi. I'll show you that you won't necessarily need to on this one, but actually let me just start graphing and show what I'm talking about. So this is at 4. This goes down to negative 4. So at 0, I need to go out to 4. 1, 2, 3, 4. At pi over 6, I'm back to 0. So it starts here, but before it even gets to that pi over 6 line, it's back to here. At pi over 3, it's at negative 4. So pi over 3 is this line right here, but you need to go backwards. 1, 2, 3. And then by the time you get back to pi over 2, it needs to be right here. And then at 2 pi over 3, which is right here, it's back up here at 4. And if you can go ahead and figure out where the rest of this goes, you can. If not, you can finish this graph to 4 pi over 3. Let's see, then this would be pi. This would be 5 pi over 6. So at 5 pi over 6, so that's this line right here is 5 pi over 6. It needs to be back to 0, so it should never actually touch that line. And then if you can figure out that the last leaf goes here, what ends up happening is by the time you get to 0 to 2 pi, like if I go to 4 pi over 3 over here, 4 pi over 3 is right here. And if I were to go to 4, there's already a leaf there. So what's actually happening is they also have 6 leaves. They're just on top of each other. When it's an even number there, they don't overlap like this. But this odd, this 3 leaves, there's actually 6 leaves. It's just that 3 of them are on top of the other 3. I think I'm just going to leave it at that. If you need to do any extras, you can check with me on office hours or practice them on your own with doing it by hand. If you need any more to do by hand, just let me know.